Hello and welcome to the first part of a 3 or 4 part series focusing on the design and building of my Working Stargate Miniature Project. In this first part, a progress log of what I've done so far. Again, as always, I want to apologise for taking so long to make this video. I originally aimed to get part 1 out by around the beginning of February, but as usual unexpected things happened and it took me longer than I thought it would. One of the things that delayed it was that I spent a fair amount of time researching for a job I had been approached for. I had alluded that my unemployment was about to improve in one of my last videos, and so I had used a fair amount of my time between December and late January doing research for this role. But sadly, even though things seemed to be moving in a very positive direction and though I had no doubt in my mind I was able to do the job, it didn't happen, which was a huge blow for me and felt like a kick in the guts. I've also used some of this time to get a few other projects started and in the pipeline, but there will be more videos about them in the coming months. So going way back to the end of my last main project video, the retro gaming handheld, I said that my next main project will be the Working Stargate Miniature. At around this time I had already begun modelling some parts of my Stargate, but I then put that aside till the beginning of January. Using some newly found references, which at the time I thought were from the official Stargate blueprints, I started modelling the Stargate, wanted to bulk out and get the main aesthetics and looks right, before figuring out how to make it all fit together in the real world. Many of the shapes and patterns were pretty simple, so I ended up using the array tool a fair amount, but as some of you might know, Fusion 360 still has some issues when dealing with complex geometry. So I had to also tackle random slowdowns and crashing bugs as the project got more complex. Once I modelled most of the gate, I started to give some thought as to how it was all going to fit together. I already had some ideas in my mind, but if they were going to work was yet to be seen. I knew the main dialing ring was going to be on a gear and driven by a stepper motor, so I modelled that first. And it was around this time that I started to give some real thought into what materials I was going to use. After doing some research, I decided to use POM, also known as Derlin plastic. This plastic is perfect for this kind of project. Not only is it naturally low friction, which is why it's often used for bushings, it's also very stiff and resilient to damage, and it also laser cuts really well. And unlike acrylic, it's also not brittle, so it makes it perfect for gears. The main downside to POM is cost. It's one of the more expensive plastics available. I am currently expecting to spend around £70 for 3, 4 and 5mm sheets for laser cutting. And again, because of its stiffness and low friction, I'll be also using it to make the main framework. One of the first problems I ran into was trying to figure out how to stabilise the dialing gear for the Stargate, to stop it moving backwards and forwards. I came up with many ideas using various bearings that would hold it in place. I had even considered making my gear some kind of floating bearing Lazy Susie, with ball bearings fitted inside the groove around the rim, but I don't have access to the precision tools I would need, such as a profiler mill, to make such a bearing setup. After about a week or two of trying to figure out how best to deal with this problem, I decided to just use some rolling idler gears to keep the dialing gear fixed in the X and Y, and use my POM frame to sandwich the dialing gear to keep it fixed in the Z plane. The main downside to this will be noise. While POM is a great low friction plastic, there will still be some grinding and rubbing, and so this will certainly be noisier. How much noise remains to be seen or heard, but going down this sandwich route solves some difficult problems when working at this scale, and with the tools I had on hand. I may look into this again before laser cutting and constructing the gate, but for now this is what I have. At this point I took some renders and showed them to some of the members of the SciFiMeshes.com community. This is a great place I used to be involved with quite a lot back in the day, but had reconnected with over the last year. This is a great community of fans of sci-fi 3D modelling and visual effects that has its roots all the way back in the late 90s. It sadly died down over the last decade after persistent cyber attacks and changes of ownership, but it has started to come back this last few years, with some original core members of the community taking ownership. So why not check them out and consider joining if you're into sci-fi stuff. While on the whole they did like the model and the detail, they confirmed something which I had been suspecting, my gate was thick. It turned out some of the reference material I was working off wasn't actually from the official Stargate, but some rough sketches from the team behind another full-size Stargate replica project. Sadly, the cross-section drawing I was working with was a bit rough, so I got some of the measurements wrong. But members of the community luckily had some screen captures of the official cross-sections that were sold off at auction some time ago. And as luck would have it, the taper angle of my gate did mostly match that of the cross-section, so for the most part, moving the faces back and in line with the original cross-section was a relatively easy job. However, it did take me a while to correct every part, and did mean I needed to rethink and rework much of my frame design to fit the new thinner profile. And in the end, I ended up with a gate design that I was much more happy with. With the visual design pretty much done, I started to figure out and model exactly how it was all going to fit together. I modelled in lips and slots for intersecting parts to be glued, and even added some holes where screws could be placed in for a more secure fit. With all the framework and the screws and interlinking model parts, I should have a pretty solid and self-supporting model. One of the big challenges I faced in the modelling was figuring out how to add the greeble effect on the inside ring and underneath the chevrons. In Fusion 360 it's near enough impossible to get this kind of effect in your design, as it doesn't support placing shapes on curved objects, and then extruding across the normal face. So what I did was draw the greeble shapes in Fusion 360 and convert them into a vector file which I could then take into a drawing application to create a height map. After that, I created the base models for the greebles to be applied to and exported them as STL files. I then imported those STL files into my 3D software that I used to use back in the day, fixed up the geometry and corrected any unwanted edge lines, and aimed to get a roughly even space quad layout. I then set the UV projection of my model and applied the texture to the faces where I wanted my model to have the greebles. I then tweaked the scale of the UV, and once I was happy with the greebles textured scale, I then reselected those faces and tessellated the hell out of my model. I ended up with a super dense mesh with roughly 32 to 64 million polygons, which maxed out my 32GB of RAM and regularly crashed 3D software. The reason I had to make my mesh so dense was twofold. Not only did I need to get my mesh density down to the scale of the voxel resolution of my 3D printer, but I also need to deal with the aliasing effect that I'll get between quads when the curves did not quite align with the edges of the greeble's relief effect. After I was happy with the height, I then collapsed my mesh, which freed up some memory, and then applied the optimizer plugins to reduce the poly count into something more reasonable. While the optimizer did make some of the edges rough, this is still in a really low scale area and probably wouldn't translate into the 3D printed model. I resaved these meshes into OBJ files and placed them back into my Fusion 360 project to make sure the greebles didn't intersect with other parts of the model. For the most part they were fine, but I did need to cut out some small sections of the mesh to make it fit better. The next big thing I needed to tackle was actually something I was starting to dread: the chevron locking mechanism. By this point I had decided that I will be following the TV show style of locking effect, that being that only the 12 o'clock chevron would mechanically latch on the selected symbol, and this part of the design ended up taking a long time to figure out, as I went through roughly 7 or 8 or 50 different design iterations before I settled on my final design. The first issue I had was the unequal distance that each half of the mechanism travelled, with the triangular chevron moving down 10mm and the light crystal moving up by 5mm. The first design idea I had was to have a rotating arm, with levers on pivot points that would push the sliders up their guides and back down again. This proved to be really difficult at this scale to design, and created pressure points that would likely have binded the sliders in their starting positions. After trying out 2 or 3 designs with this method in mind, I moved on to an idea of using a slider that would sit between the 2 halves of the chevron, with the slider having different gradients of slope on each side to push the chevrons into the open position. But sadly again, with this scale I was working with, and the tight confines of space in the model cavity, I wasn't able to make this fit. With this, I was playing with the idea of using springs that would pull the sliders into the closed position, which led me to start thinking about using wired pulleys to pull the sliders into the open position. And after toying with this idea for a couple of days, I realised again I didn't have the space needed, as there would not be any space for the fishing line to pull the chevron up into the open position. So I reversed this idea. The springs would now pull the mechanism into the open position, and the servo controlled wire would hold the chevrons in the closed position, and release it to the tension of the springs to pull the chevrons open. At this point I went through about another 3 or 4 designs, mostly trying to find the optimal spring connection points. I've designed this to use 2mm diameter extension springs, which at the time I had only just ordered, and I was unsure if they would have enough tension to pull the chevrons open or closed. But by this point in the design I had spent over 2 weeks on this mechanism and I had run out of ideas, so I started to fabricate one to test. Again, this mechanism used POM plastic that would be laser cut, and would also have a resin printed parts that would connect to my model. And after making this version I realised rather quickly it wasn't going to work. At least the bottom half sandwich plate was too short and would tilt and start to bind with the frame, causing too much friction. But also the 2mm rods I had used to slide in the guide slots also allowed the plate to tilt and bind as well. So this version was certainly a failure. But it seems the principle was sound. I just needed to go back to the drawing board and try to fix those issues. And I still needed to do something about the springs. I got these springs off AliExpress as I struggled to find any extension springs suitable at a reasonable price locally. £2 to £4 per mini spring with a minimum order of 100 is not what I call reasonable. However, the tension is a little on the weak side, and I wasn't even sure, even with the rails moving freely, if they would be strong enough to pull the plates into the open position. So I went back to Fusion 360 and started tweaking the design again. Firstly, I swapped out the 2mm rod strips with POM plastic as guide rails, but because of the increased size, I had to limit my bottom half's movement from 10mm down to 7 or 8. I wasn't too happy with this, so I went back with the rods but added sidewalls. That combined with a longer sandwich plate should restrict the two halves from twisting and binding. Doing this means I could keep my full 10mm of movement for the bottom half. But I'll keep the strips idea in mind as a plan G. Though by this point I've gone through so many revisions on this design I've made my way right past Z and back to A before I lost count. I then reworked where the springs connect to help increase the tension. This includes adding this little nipple on the middle of the top half of the chevron mount. Hopefully the Elegoo resin would be strong enough for this scale not to snap. We certainly don't want any snapped nipples. By this point I then realised I had made a horrible mistake with how the triangle chevron attached to the mechanism. The chevron model had arms that I had planned would slot in through the front of the model and then get screwed into the mechanism. But I started to realise that would be impossible when the model was being assembled, as there would be no way to reach the screws, let alone wire up the lighting. I had to then redesign the way the chevrons attached to the mechanism, this time with the arms being part of the mechanism and poking out through the front of the model, to which I could then glue the chevron onto. I've still not quite fully figured out how the lighting would fit into this, but I'm sure it's something I can figure out a little down the line. And after a few more minor tweaks to the design, I came up with this mostly working mechanism. The two top half springs are still a little on the weak side, but I'm hoping once I receive the 2mm diameter springs, the slight tension increase will be enough to make the top half's movement complete. The plan is to have a little pulley attached to the end of this loop, and more fishing line fed through a Bowden tube to a servo hidden inside the pedestal. This servo will pull on the loop that will hold the chevron in the closed and locked position. The only question right now will be, is the servo strong enough to pull the pulley without stalling, as this does take some level of force to pull this all the way closed by hand. So I created this rig to test just that, and it doesn't work, so I'm going to have to look for a larger servo. Just before wrapping up this video, let's have one last look over the construction of this gate. Starting with the laser cut dialing gear, the printed symbols will be epoxy glued onto the slots and secured with a screw on the back. The main gear will be sandwiched in the frame with the idler gears securing the dialing ring in the X, Y and Z. The inner greeble ring is slotted onto the frame with the guided slots. The front and back faces with the greeble attachments will be secured onto the greeble ring with the screws and glued to the slots in the frame with epoxy glue. The chevron frames will be placed down onto the greeble rings and frame and then screwed down, securing the greeble rings to the frame, and a cover is then placed over the screws. The chevron triangle and the light crystal are then glued onto the chevron locking mechanism, and then the wings are glued down onto the frame. The back sides of the inner ring mount are glued to the slots on both the frame and the back face model parts, followed by the front half of the inner ring slotted into the back half. And after that, the wormhole emitters are then glued into the cavity of the inner ring, completing the gate part of the build. So what's left to do? Well, I need to start modelling the pedestal base. While this is an earth gate, I'm going to be giving a stone pedestal as if it was an off-world gate. Because it's going to have this stone look, I'll be doing some base modelling in Fusion 360, mostly for the mechanical construction side and for keeping the accurate measurements, but I'll be taking that model into some sculpting tool to give it a final look. I may also do some heavy post-processing to really give it that proper miniature quality, including a lovely shrubbery. I also need to design the electronics for this thing, as well as a working DHD. I'm not entirely sure what I'm going to do with the DHD, as truth be told, while I love the Stargate TV series and the gate model itself, I've never really been a fan of the DHD design. I've always felt it looked a bit naff. So expect me to come up with a different design for the dialing controls. Once I have all that locked down, I'll start printing and fabricating parts. I'll be using my Anycubic photon to print out the high detailed masters with Elegoo ABS-like resin, printing out each part of each section, and then I'll make silicon molds and do resin casts to duplicate them. This being a far cheaper and quicker way to make each section, as casting resin is a lot cheaper than printing resin, and also cures far quicker than it would to take each part to print, with each part taking roughly 24 hours to print. Now for the self-serving bit. These projects are not cheap for me to make, and while I am unemployed and looking for work, they are an extra financial burden. But one I am willing to endure so I can keep my brain active and so I can stay creative. I also do these videos because from the feedback I've been getting, people do enjoy watching them, and so I want to make these videos for you. If you like these projects and want to help support me, please follow the link to my GoFundMe page in the description, and please consider making a donation. Also, if you are new to my videos and have not done so already, please consider subscribing. As with each new subscription and viewer, I'm getting closer to being able to start monetizing my channel, which over time will help fund my projects in the future. I hope you enjoyed this video, and I'll see you in the next one. Take care.